Hi guys, Dr. Justin Souther here, going through some tutorial questions on limits and continuity, and we asked to find the limit if it exists, or show that the limit does not exist of this guy over here. Limit as xy approaches 0, 0, x squared sine squared y all over x squared plus 2y squared. Now always the first thing to do is just check that it's not a continuous function, because if it's a continuous function you can substitute in. Of course, if we substitute in here, we end up with 0 squared plus 2, 0 squared, 0 in the denominator. Okay, so we can't substitute in. Second thing to check is, unless you know where you're going and know how to show that it exists, is to check that the limit doesn't, see if it doesn't exist. Try a couple of lines. So approach on the x-axis, approach on the y-axis, approach on the line y is equal to x, approach on the parabola, y is equal to x squared. And once you've kind of convinced yourself that that maybe it does exist, then you look for another proof. In this case, we're going to use the very handy squeeze theorem. So how do we start? Well, the first thing to note is, and there's always a little bit of a trick to this, is to note that x squared, it's positive. Okay, so x squared is greater than or equal to 0. And x squared is also less than or equal to x squared plus a positive number. So y squared is positive, multiplied by 2, it's still positive. X squared is less than or equal to x squared plus a positive number. We're going to now divide through by x squared plus 2y squared. Always when you're dividing an inequality, make sure that if you divide by a negative number, you switch over the inequality signs. Of course, in this case, we're dividing by a positive, so we don't have to worry about that. 0 divided by that, well, that's still 0. 0 is less than or equal to x squared over x squared plus 2y squared, which is less than or equal to, well, this thing divided by itself, of course, is just 1. Now you can see what we're doing is we're slowly building up this function over here. We've got the x squared over x squared plus 2y squared. Right, so now what we want to do is we want to multiply through by sine squared y. Again, if you multiply by a negative, you've got to flip over your inequality signs. In this case, we know sine squared is positive, so we don't have to worry about that. So we got 0 is less than or equal to x squared sine squared y all over x squared plus 2y squared, which is less than or equal to sine squared y. And you can see why it's called the squeeze theorem, because we're squeezing this function between these two over here. Now, of course, the squeeze theorem is comes into play when you take the limits. So the squeeze theorem says that if you've got these functions here, we can take the limit of the first one, xy is approaching 0, 0, of 0, that's less than the limit of the second one, xy is approaching 0, 0, of x squared sine squared y all over x squared plus 2y squared, which is less than or equal to the limit of the third one. The limit is xy approaches 0, 0, of now sine squared y. Okay, now how does that help us? Well, over here on the left hand side, we've got the limit of a constant. The limit of the constant is simply equal to a constant, so this thing here is simply equal to 0. And on the right hand side, we've got the limit as x approaches 0 of sine squared y. Well, sine y is just a continuous function, and we've got y approaching 0, so we can simply substitute in. This is equal to the sine squared of 0, and that of course is equal to sine of 0 is 0, and 0 squared is just equal to 0. So we've got 0 here all the way on the left, we've got 0 here all the way on the right. That means that this guy here in the middle, which is what we're trying to work out, is squeezed between the value 0 and 0, so it must be equal to 0. So therefore we can conclude that the limit as xy approaches 0, 0 of x squared sine squared y over x squared plus 2y squared is equal to 0 by the squeeze theorem. It's a very nice example, this one, of the squeeze theorem. Remember also, when you're proving that a limit exists, you can do things like factorizing and cancelling out between numerator and denominator. Maybe you have to rationalize the denominator. There's a nice exercise that requires you to do that. But this one was a squeeze theorem.